ASMR sleep station. My throat's already getting whistly. I'm going to save all the reviews and stuff like that for the end, and I'll just start off with some content since that's probably why people download this, and it should be pretty sleep inducing. At some time I'll probably read some more from that book, which is all on genomics, and I'll switch to another topic that most people probably don't read a lot about, and that is wave particle duality in physics. And this is an article that I found on the Wikipedia page for quantum eraser experiments. This paper is called Quantum Non-Locality in Two-Photon Experiments at Berkeley. And there's no way I can pronounce these names correctly, but it's by Raymond Y. Chow, Paul G. Quiet, Ephraim M. Steinberg, and this is all from UC Berkeley, which is a very prominent school in the area of physics. If you even studied it in your primary education, you probably remember the element berkelium on the periodic table. That's at the bottom of the chart, way at the bottom. It has a really short half-life, but that was discovered at Berkeley. I don't remember who, but Berkeley has quite a reputation for physics, and this is an interesting paper, but like a lot of the stuff I'll read in these recordings, it is dry. It's a little bit mesmerizing. It'll probably put you to sleep. It's very hard to follow if you're not looking at the text, so I'm gonna read as much as I can. I've been a little short on time lately, so I'm behind about a week. I apologize for that, but as I've mentioned before, I'm going to try to be as regular as I can. It won't always happen, and bear with me if you have to wait. There will always be another recording, at least for the foreseeable future. I think this is working out well, and it's helping a lot of people get relaxed and get some sleep. And yeah, that's all I have to say about that for now. Okay, so we'll start off reading this paper. It's and I can't find out where's this thing published. I found it on Arvix. And this is a reprint. Looks like a reprint from Quantum Physics. This version is from December 21st, 1994. Okay, so before the introduction it says, we review Some of our experiments performed over the past few years on two-photon interference. These include a test of Bell's inequalities, a study of the complementary principle, an application of EPR correlations for dispersion-free time measurements, and an experiment to demonstrate the superluminal nature of the tunneling process. The non-local character of the quantum world is brought out clearly by these experiments. As we explain, however, quantum non-locality is not inconsistent with Einstein causality. Okay, so this is the first section, introduction, which shouldn't be too heavy, and I probably won't even get that far because this material is so dense, and I'm really making an effort to read at an even pace that's not too hasty and won't really react with any listener that's subject to getting excited with fast reading. I have no idea if it's true, but I would imagine if somebody's reading something really quickly, it might make your blood pressure go up a little bit, and the slower reading calms you down. So we'll see how far we can get, and if this works out, we can keep reading it, because it's actually pretty interesting. If you don't know anything about non-local physics or photon interference, quantum eraser experiments, and you're at all interested in physics, then I highly recommend reading this article and others. It's some fascinating stuff. So, this is section 1, introduction. We shall begin with a brief review of the Einstein-Podolsky-Rosen paradox, EPR, and then review some of our experiments at Berkeley, the Franzen experiment, the quantum eraser, the dispersion cancellation effect, and tunneling time measurements. Let us begin by stating that we consider the EPR phenomena to be an effect, not a paradox. EPR's experimental predictions are internally consistent, and a contradiction is only reached if one assumes both EPR's notion of locality and the completeness of quantum mechanics. QM. The three central elements that constitute the EPR argument are 1. A belief in some of the quantum mechanical predictions concerning two separated particles. 2. A very reasonable definition of an element of reality, that's in quotes, element of reality, namely, that, quote, if without in any way disturbing a system we can predict with certainty, i.e. with probability equal to unity, the value of physical quantity, then there exists an element of physical reality corresponding to this physical quantity, end quote. And 3. A belief that nature is local, i.e. that no expectation values at a space-time point x2 or x sub 2 can depend space-like separated point x1. This definition of locality is now seen to be more stringent than Einsteinian causality and is inconsistent with quantum mechanics. I'll keep using QM. In the original EPR scheme, the system under consideration is a pair of particles described by the wave function sigma x1 minus x2 minus a. This is a simultaneous eigenstate of the operator x1 minus x2 with eigenvalue a by the wave function, and the operator p1 plus p2 with eigenvalue 0, which is possible since the commutator x1 minus x2 comma p1 plus p2 vanishes. In other words, the sum of the particles' momenta is well defined, as is the difference in their positions. Therefore, if we measure the momentum of one particle, we can predict with certainty the momentum of the other. Hypothesis 1. Even though it may be sufficiently far away that no signal could be transferred between them. Hypothesis 3. Momentum must therefore be an element of reality. Hypothesis 2. And if we measure the position of one, then we can predict with certainty the position of the other, possibly distant particle. Hence, position is also an element of reality, but quantum mechanics does not allow a precise specification of both the position and the momentum of a particle. This was not a paradox to EPR. Rather, they concluded that quantum mechanics must be incomplete. A complete theory would not contradict the predictions of QM, but would incorporate all elements of reality, just as atomic theory incorporates the positions and momenta of individual atoms, variables not described by thermodynamics. The first figure in this article is Bohm's version of the EPR Gedanken experiment, which I think is just a thought experiment, and that shows two particles originating from the same source, and it looks like they terminate in two different, I don't know what those are. Those are maybe something to do with optics. They do have arrows that might mean a vector of some sort. Figure 2 is the optical version of EPR experiment, and that shows a similar diagram. It looks like they're gamma rays, maybe rays that decay, and they both terminate in something. Oh, they're filters. Alright, so I'll read the passage that's below the diagram. I don't really know why I'm trying to explain this like you're really listening. You shouldn't be listening. Hopefully you're nodding off and you find it hard to pay attention. In Bohm's version of the EPR experiment, see figure 1. A spin-zero particle decays into two spins, two spin half particles in the singlet state. The equation associated with that singlet equals 1 over the square root of 2 multiplied against bracket absolute value up 1 down 2 minus up 2 down 1 in bracket. In each of those terms, it looks like they're absolute values. The filters A1 and A2 in Figure 1 are Stern-Gerlach apparatuses, optical versions of this experiment performed by Friedman and Clauser, and by Aspect et al. Used photons in place of their spin. I think that's spin 1/2, 1 over 2 particles, and linear polarizers P1, P2 in place of Stern-Gerlach apparatuses. See Figure 2. The coincidence count rate as a function of the relative angle between polarizers P1 and P2 is a measure of the correlated behavior of the two separated particles. Bell derived an inequality starting from EPR's very general and seemingly reasonable notions of locality and realism. This inequality is violated by the high visibility sinusoidal fringes predicted by quantum mechanics. Most importantly, experiments yield results in agreement with quantum mechanics and in violation of this inequality, modulo some reasonable auxiliary assumptions about uncounted particles. Therefore, these experiments rule out a broad class of local realistic theories. These early experiments relied on the correlation of the polarization, i.e., internal degrees of freedom, of the particles. Since the predictions of quantum mechanics are so strange, it is important to investigate them for external degrees of freedom as well, such as the momentum and position of the particles considered in the original EPR paper. Rarity and Tapster have already done so for momentum and position, and recently we have performed an experiment first proposed by Franzen, relying on the external variables of time, of energy and time. We're not into even the meat of the article yet, and it's already getting pretty heavy, but this is fun. I hope it's relaxing. Section 2 is titled Entangled States, and I'll read this for just a few more minutes. I have to cut it short, and I apologize if I'm cutting this recording shorter than you'd like. Erwin Schrödinger, in response to the EPR paper, pointed out that at the heart of these non-local effects is what he called entangled states in quantum mechanics, i.e., non-factorizable superpositions of product states. For if a two-particle wave function were factorizable, I don't know what that symbol is. I'll skip all the equations. It's not even worth reciting. Then the probability of joint detection would also factorize, so that the outcomes of two spatially separated measurements would be independent of one another. In cases where the two-particle state cannot be factorized as above, this means that the quantum mechanical prediction implies non-local correlations in the behavior of remote particles. Bohm singlet state is such an entangled state. It predicts correlations between spin measurements made on the two particles, but these correlations persist even if the particles and their analyzers are separated by space-like intervals, implying the existence of non-local influences. Though each particle considered individually is unpolarized, the two particles will always have opposite spin projections when measured along the same quantization axis. Einstein et al. Would conclude that each spin component is an element of reality and that it would be possible to predict its value with 100% certainty without disturbing the particle simply by measuring the corresponding spin component of the particle's twin, a measurement which, according to EPR's locality hypothesis, cannot disturb the particle in question. As discussed above, this reasoning led EPR to conclude that quantum mechanics was incomplete. If one instead considers QM to be a complete theory, one must then admit the existence of non-local effects, as we shall see below, experiment supporters of this latter interpretation. In our experiments, the entangled state we start with is an energy-entangled state of two photons produced in a two-photon decay process known as spontaneous barometric fluorescence. The Feynman diagram for this process is shown in Figure 3, and the state of the two-photon system after decay for a parent photon with a sharply defined energy E0 is given by, there's an equation I'll skip. In Figure 3 shows gamma 0 splitting into gamma 1 and gamma 2. Instead of a sum, as in the singlet state, we now have an integral since energy is a continuous variable. The meaning of this energy-entangled state is that after the measurement of one photon's energy gives a sharp value E1, there is an instantaneous collapse to the state. This effect has been seen in earlier experiments in which coincidences were recorded between photon gamma 1, which passed through an interference filter to measure its frequency and hence its energy with high resolution, and photon gamma 2, which passed through a Michelson interferometer to measure its width. When photon gamma 1 was detected after the narrow band filter, photon 2 collapsed into an equally narrow band energy state, whose coherence length was then far greater than that of the uncollapsed state. I'll stop there for now. If I ever pick this up again, we will start off on section 3, the two-photon light source. And this is just basically setting up the background for the different experiments that were used to measure photon behavior and what you can deduce from that behavior. The implications of these experiments has to do with physics, locality, non-locality, and that starts to approximate what we know and what we can describe and predict about reality using our current physics models. So this is very important. I guess if you're interested in what reality is and the behavior of light and matter and how all those things are connected, it's really interesting. And maybe after I read some articles, which I'm just reading because they're very dry, we can read some more popular science types of reviews on these articles that will put everything into perspective, into layman's terms that we can understand, because the physics aspects of these articles are pretty intense, and I don't think you'll get them unless you're somebody who studied physics in college, or you read it for fun, which I doubt. I don't think anybody reads these for fun. And the last thing is just an update on the iTunes page. So after 11 recordings, there's 27 ratings, 16 5-star ratings, 6 4-star ratings, 3 3-star ratings, 1 2-star rating, and 1 1-star rating. Thank you, everybody who rated this. I appreciate you taking the time. I don't remember what I read last time. I think I read the review left by Rachel, and I think I read the one by ASMR Check. That one was very brief. It said, "Awesome, this really helps." If I didn't read those, then I'll thank you now. Thank you for leaving those. The new ones, there's two. The first one is titled ASMR Sleep Station is So Wonderful by Starlight Lady 59, left February 1st, 2015. The review reads, "It's great." So, thank you for leaving that. I appreciate it. The second new review is entitled "Got My Sleep Back" by Mega Pain, left February 3rd, 2015. And the message reads, "I only have you to thank. You're my savior of sleep." And there's a unreadable symbol. It looks like a square. I'm not sure what it is. I think my font set is kind of limited on my computer, so I couldn't read it. But you're welcome to both of you. I'm glad this is helping people sleep. That is the entire point of everything I'm doing. And it's working. So I couldn't be more pleased with the way things are going. And yeah, I'm a little short on words today, but I really appreciate everybody who's left ratings and reviews. And hopefully I'll have another recording out in a week. I had a small vacation, and the time preceding and following the vacation has been a little busy, but I should be back on track, and I believe my week will be a little bit shorter than normal next week. It may not be, I'm not sure, but either way, I'll find some way to get another recording in. No more vacations for a while. So, I hope everybody's doing well. especially your worries and anxieties, and you can forget them. Get rid of that stuff, shed it, and just relax. And if you're trying to fall asleep right now, then I hope you're asleep. I will, I'll whisper